Assalamualaikum and good morning everyone. For this video, you will learn about the introduction for the first order differential equation. So I will explain about what is the differential equation. So an ordinary differential equation, or the notation of the ODE, is an equation that contain one or several derivative of unknown function. So derivative means that we have the terms of dy over dx. So means that if you have any equation that consists of dy over dx, y double prime, d cube y dx cube, so all of this we call as a differential equation. So the standard notation for the differential equation, we can write in terms of dy over dx, y prime in the bracket of x, and also in terms of y prime. So it is similar for the second order differential equation, whereby the second order is d square y dx square y double prime. And in general, the nth order of the differential equation can be written in terms of dny dx the power of n, whereby n here stand for the order of the differential equation. Okay, so now for the order of the differential equation, how we want to determine what is the order for that differential equation. So the order of the differential equation is determined by the highest order that appear in that differential equation. For example, for the first equation, we have dy over dx. So the highest derivative that exists for this equation is first order, or order 1. Okay, for the second example, we have x square d square y dx square, and then here we have dy over dx. So the highest order is d square y dx square. So this is the second order. So in order to determine the order of the differential equation, we refer to the highest order that appear in that differential equation. So for the third example, the highest order is y double prime. So this is also the second order. And for the third one, we have y cube or y triple prime. So this is the third order. And for the last one, we have d4 over dx4. So this is the fourth order. Okay, and the next one, you will learn on how to determine whether the equation given is a linear or non-linear. So the differential equation is said to be non-linear if the derivative has power more than 1. So what I mean by the derivative has power means that for the derivative dy over dx, you have power outside the derivative. Okay, so for example, dy over dx, so the whole thing here with the power of 2, y prime with the power of 3, dy over dx with the power of 3. So this differential equation will become a non-linear if the derivative has power. Okay, so we do this exercise. Determine the order of the following differential equation. So for the A here, the highest order that appear here is the first order, which is dy over dx. So the second one is du equal to d square u dx square. So this is the highest order, which is the second order. For the third one, you have y triple prime. So the highest order is third order. And for the last one, we have d square y dx square with the highest power. So this is the second order. And for the next example or exercise, determine whether the following statement is true or false. A differential equation is identified as a second order linear differential equation. So it's mentioned here, this is the second order and it is a linear. So for the A here, we have the highest power with the power of 2. So this is a second order. But then is it linear? Yes, this is a linear differential equation because we don't have a power outside the derivative. So means that the A here, this statement is true because this is second order, correct? And this is also linear, also correct. So for the second derivative here, Second equation here, we have the highest derivative, which is d square y dx square. Yes, this is true, the second order. But then is it linear? So the b here, this is not a linear differential equation because we have dy over dx with the power of 2. So for this statement, this is false because even though this is a second order, but this is a non-linear. Okay, why non-linear? Because we have dy dx with the power of 2. Okay, so from this video, you have learned on how to determine the order of the differential equation, and then you also learn on how to determine whether the equation is linear or non-linear. Okay, so that's all for this video.